My name is Michael Aller, and today I want to rant a little bit about the primary data asset system, as well as how to proxy actors and how to share data across different mechanical parts of your game. Now, this is going to be sort of a weird kind of deep dive into something very specific, but also not very deep at all, and it's going to consist of a lot of rambling, but hopefully if you can follow along, maybe some of this is useful if you're interested in anything about the primary data asset system or how to have an actor represent another actor. And I'll go more into what I mean by that in a bit. Now, there are many reasons why you would want to proxy an actor or proxy some sort of data in the world, whether it's you have a weapon that you can pick up and you don't want the full-fledged weapon actor that a player might have attached to them in the world at all times. You might want a lighter weight, just item pickup actor, and when you pick up that item, it then grants you the real weapon actor. There are a lot of reasons why you would want to sort of replace the idea, the mechanics of something with one actor to another. And I'm going to be showing how I go about this design using the primary data asset system. Now, before we get into that, I want to talk about how you might approach this without the primary data asset system, or just if you're new to Unreal or you're just not exposed to some of the more asset discovery stuff that exists. So one way that you would typically look at this is you would have a class, a blueprint, such as your main weapon class, and then anything you are proxying, you would just in your proxy have a reference to that real class, if you will. So you might have a weapon pickup class that inside that class references a weapon usable class. And the weapon usable class might have all the data definitions for what does that weapon look like, what mesh does it use, what material overrides does it have, how fast does it fire, all of that. And that's a pretty simple, straightforward approach. You can always spawn one of these weapon usables and pull data from it. But therein kind of lies in the problem. In Blueprint, you would have to spawn the actor because it's a little tricky to get what's called the class default object of some of these actors in Blueprint if you're dealing with a lot of Blueprint logic. And there are a whole bunch of exceptions and all kinds of weird stuff you can do with class default objects. I'm not going to go into that with this, but that is a road you can go down, and generally the roads that you go down to facilitate that end up becoming maintenance problems in the future. They become weird hard reference chains of circular dependencies, and just a lot of weird stuff happens when you try to scale that up. So this design pattern I want to show you today to solve that problem sort of addresses both the scalability, the maintenance, and also makes these things easier to use and to develop with. But it does require some knowledge of some systems that aren't immediately apparent in Unreal. Now, before I get into that, I want to talk about two actors I made that we're going to proxy. And right now, I'm just in the third person template, and I've changed some stuff. I've cleaned up the project a little bit. But there are three folders I have: core, items, and tools. And I'll go through these as we talk about this. But in my items folder, I have two items. Now, in my case, my definition of an item is just a thing in the world, right? But you have to think abstract here. This can be an item in your inventory that you later equip, or some sort of logical state on your character, like a bit flag that you have a key, what have you. In this case, item just means a thing, and that'll be more emphasized in a bit. So I have two items in my game. I have Death Orb and Yeet Cone. Now what the Death Orb does is real simple. If you touch the Death Orb, it deletes you. That's all it does. It's real simple. That's all it needs to do. Now I have the Yeet Cone, which is also real simple. You touch it, it yeets you up into the air, and then if you land on that box collision, then you end up killing yourself. All right. So these are our two items in the world. Pretty simple. Now, imagine if these were inventory items or weapons or whatever. You can and you would need to proxy them in a variety of different ways. So instead of focusing on why you would want to proxy things, just from this point, assume we want to proxy these two things, and we'll move on from there. Now, the ways you can proxy these things is, once again, having a class that you pull data out of and having references to that class that other things need to know about and all this stuff. But the other more unreal way to do things is using the asset manager system. Now, there are many names for this. There is the asset manager, there's the asset registry, and there's just called primary data assets. These all refer to the same underlying system. How I like to think of it is primary data assets are the actual data assets that you're moving around. The asset manager is just a tool set that is built on top of the asset registry, which is how Unreal registers and stores and scans and collects all the assets on disk or dynamic assets or what have you. So the asset manager is tooling that lets you work with the asset registry, and primary data assets are one of the tools that the asset manager provides. Now, if that doesn't make sense, it's going to get a little weirder, but hopefully at the end of this, it'll all kind of come together. Now, first we have to discuss what is a data asset. And if you're using Unreal, you might notice that under the miscellaneous, under the new content pop-up, there's something called a data asset. And there's all these different things. If you use Blackboard, or if you use just some of these things before, you'll have made a data asset before. Now, a data asset simply is a U object that is tagged with, hey, this has data. And it's really that simple. Here we're seeing a C++ definition of a data asset I made for this project that I will explain more in a bit. But if you look up the chain as to what a data asset actually is, it's just a U object that has a bunch of tagging and other stuff related to it. It's basically a U object that the asset manager knows to look for and knows how to deal with. All right. So what the asset manager does for us is it's encapsulating a lot of asset discovery, a lot of asset loading, and just asset referencing for us. But you kind of have to know what it does in order to use it, but you have to use it to kind of know what it does. It's a little bit of a weird system. So the entry point to the asset manager is confusingly in your project settings, and you can see under game, the only two things under the game category are asset manager and asset tools. Interesting. So by default, you have map and primary asset labels, and you'll see here that I have what's called a thing data asset. Now, what this configuration means is when the engine starts up, when new assets get loaded, when new assets are deleted, like when the asset structure changes or gets loaded at startup, Unreal is going to take its asset manager, comb through the asset registry, and look for what Unreal calls primary data assets. And it essentially looks up and caches and monitors all these assets for you. It's all running behind the scenes. You don't have to really do anything other than inform the system to scan for these things. And by default, again, all maps are scanned. Something called primary asset labels are scanned. But you can add your own primary data assets to this. Now, I've added my own primary data asset. And what this data asset is literally an asset that stores three things. It stores a reference to a static mesh, a display name, and a class. Now, I'm using soft references here. You don't have to use soft references, but the further you get into data management, the better it is to use soft references, because there's a whole bunch of cool asynchronous loading things that you can do with data assets. I'm not going to cover any of that at all in this rant, but basically you can tag certain parts of certain data assets as asset bundles and make it so that when the data asset is loaded, instead of loading the entire thing, you can load, like, I just want the meshes, or I just want the UI art or whatever, and it allows you to control async loading of this stuff. Really, really kind of neat, but it takes a while to get used to and takes a while to get in there and figure it out. But this data asset definition is literally just these 3 U properties and nothing in the body. Now, it is recommended, and you should do this. I'm not doing this for this example, but you really should look into implementing get primary asset ID and returning your own ID. That's not really complicated, but it's something that is important to look into when you go down this road and do it yourself, if you do so. All right, so all this is to say that we now have assets in our content browser that just store these 3 things. And before I get into how we create one, let's just take a look at one. Here is a data asset called thing yeet cone. We can see that it has these 3 properties, and it's a subclass from thing data asset. And in the content browser, you'll notice that it knows it's a data asset. This isn't your standard U object or U asset of some kind. It's not like a static mesh, but it's also not like a blueprint class. It's just a data asset. And so data assets, put another way, imagine if you had, well, it's an alternative to storing class references in order to reference a class default object. A data asset is basically a class default object, but it only exists as a class default object, but it's not really a class default object because it's not a class. It is just an object of a subclass, but it can be treated like a CDO, which means you can use soft object pointers to it, but because these things are singular and they're managed by the asset manager, you can kind of rely on them on being sort of static things of data. Even if you pull them in externally at runtime, they might be created dynamically, but they're generally seen as static. And yes, they are technically mutable, but you maybe not shouldn't do that. Objects that work in replacement of hard referencing a class of some sort of actor. And I know that's not the best explanation, but here we go anyway. So these data assets, they're special in that you have to create them using the data asset pop-up. And when you have a primary data asset, that your asset class shows up here, you create one, and it shows up as this icon. If you try to make a blueprint class out of this, which you can totally do, by the way, you'll see that it's got the right icon, but it's got the wrong color. Now, this is a little silly, in that this blueprint class will not function as a proper data asset. It might end up being its own definition of a data class asset, which is just a whole can of worms on its own. But this is not going to work within the asset manager system. It just isn't. You have to use the data asset creation here for making data asset assets. Otherwise, technically, you're not making an asset, you're making a new data class. Which is why, again, when these things are used as if they're class references, it's important that they're not different classes. They're just assets of your primary asset type, such as thing data asset. Again, I'm going to be repeating the same thing in many different ways because I know every little repetition doesn't make 100% sense on its own. But again, hopefully at the end of this, if you're still following along, my design thoughts and process for this will kind of make sense. All right, so now we have the concept, the idea of an asset that can be treated like a static class, but is in fact an asset, right? And these assets are scanned by the asset manager on game startup and when assets change. And because we can query into the asset manager for assets, this provides a new way for us to reference data and to warehouse data and to open up all kinds of new mechanics because the asset manager is also able to create primary data assets again externally. So you can set up a JSON service or something to pull remote data, convert it into primary data assets, and then use that within your system, which is really cool if you are say you're Fortnite. I'm not saying this is how Fortnite works, but let's just use a potential example. Now, when you load up the game of Fortnite, there is on disk already a bunch of code and actors and blueprints and things that define how the shotgun works, right? The shotgun is probably some sort of data asset with all these configuration details. Now, if the Fortnite online web server decides, hey, I want to make the shotgun fire a little faster, right? You could have UE4 query that web server, pull data down, and either overwrite or replace or add these data assets. And you can have the server say, no, you should use this data asset for this weapon when you join in or whatever. There are many ways to say, hey, I want you to use this data asset or to change the properties of a data asset. And through that, it allows you to very easily, using the same system locally, and start involving external changes, external forces as to how your data is managed and how it all works, which is really cool. And because this happens at runtime, you can do all kinds of neat things with asset discovery. And this also opens the door for DLCs, right? Because if you're able to pull stuff remotely at runtime, you can also do it with offline DLC. If you use the primary data asset system, and the asset manager, when you pull in new DLC, when the engine starts up, it will scan those assets and it will collect all that stuff for you, right? So an example of this is, say you're Call of Duty. Again, not how this works with Call of Duty, but bear with me as an example here. Say they release a DLC or some sort of subscriptions map pack or something where the game on disc, you get 10 maps, right? And you pay for something, you get a new map, right? So there are many ways to kind of fold that map into the game. Now, if you're using Unreal, that DLC is usually in the form of a pack file. And Unreal just sort of loads pack files on startup. It just loads them all. And the asset manager knows, and it does this for you, that when it loads a new pack, it adds all those assets and scans them and adds them into the asset manager. So if by default you're querying for maps or levels, which are primary asset types, you can easily query the system and go, what are all the maps available to me? And this way, when you have a player who's about to host a game and they choose a map, that choosing of a map selection can easily just ask the asset manager, what are my maps? And you can populate that list from there. And that, by doing that, it doesn't matter where your maps come from. If you have access to the map, your game will just sort of auto-populate, auto-discover, and sort of work with those maps, which is incredibly important if you're doing any modding or if you just have a large team and you want to break up like who's doing what and you just want things to sort of populate and work together and you don't want to have designers managing Excel sheets and potentially missing and stomping references and like manually assigning collections of things. Like it can get messy real quick. So having auto discovery systems for assets is kind of neat. Now, how does this relate to proxying? Well, the best way to proxy something, in my opinion, is to separate that initialization data, that configuration data, from classes, from actors altogether, right? So in my example here, I have a primary data asset called thing, right? I am introducing into my game the concept of a thing. Well, what is a thing? Well, in my mind, a thing is something that represents some sort of mechanical interaction in this game And that interaction can be represented by a static mesh, which is what we see in the world, a name for that, which is its display name, and when not proxied, it has an actual hard defined actor with its own mechanics, with its own implementation details that I know how to point to, but I might not necessarily have an instance of ready just yet. So I call that the world actor class. Now, you can have multiple versions of these things. For example, again, not saying how Fortnite works. This is just theoretical assumption. But a shotgun, for example, might have a first-person mesh and a third-person mesh. That's very standard in most games, and to have different weapon representation. Although that is becoming increasingly less likely now that performance budgets aren't really constrained around that concept. But I digress. It's very common for weapons to have multiple meshes or multiple representations to, for example, one in your hands, one in the world, what have you. So a thing could be a weapon, a thing could be an item. This is just a thing. You can add whatever you want here. My recommendation is again to use soft references so you can control loading of these things, but you can add whatever you want that represents whatever mechanic you want. All right. So my things that I want to represent are my death orb and my yeet cone, right? Those are my two things, and this is enough data to describe those things. Now, once I have that class defined, and you can do this in Blueprint. You can define your primary data assets in Blueprint. I highly, highly recommend making your data assets defined in C++ for all kinds of just usability reasons and stability. And there's a few gotchas if you use this system with blueprints. It's easier if you just keep your data assets defined in code, in my opinion. But once you have that class defined, everything else in this sample is done in Blueprint. I would do most of this in C++, but you can do it all in Blueprint. So my two items, my death orb and my yeet cone, I have my two actors that are in the world that represent the orb and the yeet cone. These are the official world actors that represent the world behavior, have their own implementations, and all of these things. But these are both things, and I want to proxy them. Well, I can describe them with my data assets, right? So I have a data asset I created called thing yeet cone, and a data asset called thing death orb, right? If you open these up, my death orb, it shows a sphere, it shows my display name, and it shows the world actor class. Now, one thing you can do to kind of make this so that you're not managing multiple points of data is that your underlying actors, your mechanical implementations of the things you represent, can also have a reference to this data, right? So my death orb, for example, it has a reference to my thing data. It references death orb. And this is how it sets the mesh. This actor itself is not setting its own mesh. It's waiting for the thing data to be passed to it. And in its parent class, BPA thing, we can see that in a construction script, it initializes from that data and does stuff. And you can override this in children classes. You can use interfaces. I'll talk more about this structure in a bit. But for the death orb here, I just want to show that it's the data that is driving the visuals in it and not the actor having uncoupled visuals from the data, right? It's the data drives the mechanics here. So if I change the sphere, for example, to, let's say, sequencer key, right? And I save this. You'll see that when the construction script reruns, the mesh has changed. Now, there are ways to make this auto update when you change this and have it auto apply. That's beyond the scope of this. But right now, anytime that data is loaded and something is initialized from that data, it pulls its visuals from that data, right? And because this data is a primary data asset, it can be auto-discovered, it can be externally sourced, it can do all these cool things. But in the actor itself, you'll see that it's very simple to just pull from this and use that data. Now, I'm using two different implementations to use this data for the sake of example. One of them is your standard, I want all my actors to be children of this particular class, and then that way I can just cast them to this class and pull details from them. That is one way to do things, and that is what the death orb is doing. The death orb is real simple. The only thing defined in the death orb is this box trigger and this event that says, if you touch the box as a pawn, destroy the pawn. Now, its parent class, however, BPA thing, this is a class that I call a core class in this example project. And what BPA thing is pretty simple, but also not quite. So BPA thing simply represents the base class of a thing, which means it's got a root component, and in my case, it's got a static mesh. It's got nothing assigned to this mesh, and this base thing doesn't actually do anything. It's just really serving as a parent class that other children classes can derive from. That way you can easily derive from this in Blueprint and get started with making a thing real quick, right? And the logic in this is pretty simple. On construct, it initializes itself from the thing. So that's cool. And the thing is exposed as a variable called thing data. And thing data is exposed on spawn, is instance editable. And this allows you that if you wanted to put something in here and assign some data to it, this will have no behavior on its own. It's just a thing. But the base class knows how to set its mesh to the static mesh in that data. All right. So this is, again, just a base class of all general gameplay things. Not what I would recommend, but this is the easiest way to start with this type of system. Now, in this actor, I have two functions called getThing and setThing. And for me, this is an interface. These are interfaces, and these don't have to be an interface. You can recreate this model without using interfaces. I have used an interface here for an example of a further point I will make later, but these do not have to be interfaces. These can just be normal functions. And in my mind, the contract around what a thing can do is really just three things. It can have a thing, and so you should be able to get that thing from it, right? So every BPA thing you can ask it for what thing data does it have? All right, real simple. The next thing is that thing for that thing can be set, right? You can set data on this actor, and it will then initialize from it, whatever that thing is, right? So if you pass this thing the death orb data, it knows to set its mesh to the orb because that's what's defined in the death orb data asset. But again, no other mechanics, nothing else is implemented. The idea here is that any BPA thing can receive thing data and then respond to it appropriately. And so anything that's derived from this can subclass this and implement their own behavior, their own mechanics as to what to do with the data that's passed into it. And in this way, you can define multiple actors for different variations of behavior with the same data if you wanted to. But I'll leave that for another talk. And initialize from thing, we'll take a quick look at this. The things that get passed in are soft references. So right now I'm doing the silly thing of just loading everything when I need to synchronously. Now you can wrap an entire async loader logic system around this, but for the sake of example, we're ignoring all of the async stuff and we're just loading it when we need it all the time. So once we have our data asset, we can then load whatever's in it. Again, the thing data asset has a static mesh that defines the representation of our thing. So it's a soft reference, so I'll load it here, but this would be the same as if you just had a hard reference and just went straight to set static mesh. It just sets the mesh in our thing to that mesh. Real simple. And that's why when you drag one of these base things and give it the death orb, it sets to an orb, or you give it the cone, sets to a cone. It's not really doing much of anything. It's just setting that data. But other classes that you define, that you derive from that, could potentially do other things. And this might seem like a very simple point to labor, but a lot of fundamental things build up on top of this of these actors can initialize themselves however they want from the data that is passed in, and that data is auto-discovered and queryable. And as we keep going in this rant, we'll see why that is important. So, we have our death orb. We know how the thing works. So it's a base class that all things are. The orb is one of those things. So how can we proxy this death orb? All right. Now, one thing I have made here is called the thing proxy. And what is a thing proxy? A thing proxy serves as a way to represent the thing that it represents, which is kind of silly to say, but this is an abstract example sample of just proxying a thing. In our case, it's just going to be another actor that looks like the actor that is going to spawn, but the act of proxying and displaying what that means is entirely up to your gameplay implementation and however you want to do a thing. But the code and the abstract technical details behind it remain the same. So this proxy, when dropped into the world, I can give it thing data. I can say, hey, I want you to be a proxy of the death orb, or hey, I want you to be a proxy of the yeet cone. And you'll see that this is indeed not the same as a yeet cone. For example, the yeet cone has its own material override in that actor, and that material override's not in the data, which is why these look different. But also, you can see that the proxy has text that clearly says it's a proxy with the name from that of what it proxies, which is defined here. If I were to change this to blah and have it reinitialize, you'll see that this thing is being entirely data driven from this. And the good thing about using soft references is if you only have proxies in your scene, the classes that they represent will never have to be loaded. So if you have a zoo, and we'll come back to that concept in a bit, if you have a zoo of these things, you can load up the map a lot quicker because they'll load proxies, and then you can interact with those proxies to do whatever you want. Now, how do you even, why would you interact with the proxy? How does this work? I have a quick example of this. It's not entirely useful, but it does show just one of the ways you can use proxies and how they can be useful, and just one of the things you can do with proxies. So my proxies have the ability to spawn their actual things at a target point. If I place a target point in the world and I select my proxy, I can choose my eyedropper tool and choose that target point, right? And now what happens here is that this proxy is basically acting as an actor spawner, which is one way that you can proxy things. You can, if you want to spawn something, but you want to visualize what you're spawning before you spawn it, this is achieving sort of that mechanic in a roundabout way. Again, what you develop as a proxy is entirely situational as to what that proxy means. Now, with the proxy selected, with the target to spawn at assigned, I can click this button, spawn at target, and this spawns the actual thing that it represents into the world. Now, I'm doing this in the editor because my proxy has a function that allows you to call spawn. So spawn at target, for example, does the spawn logic, and I'll cover this in a bit because this is touching on something that's pretty cool, but we haven't touched on yet. But the idea at spawn at target is it simply spawns the relevant actor, and in our data asset case, it spawns the world actor class actor at the target, and informs that actor on spawn its thing data. So in this case, it's spawning the yeet cone. But if I grab my proxy and I say I want this to proxy a death orb, and I spawn that target, you'll see that it spawns a death orb. All right, that's all it does. And move the target around and spawn it. And again, this works in the editor. So there is some functionality you can do for testing and stuff like that, which I'll cover in a bit as well. Now, this is cool. This is all nice and fun. And it works. It's a proxy. That's goal achieved, right? Well, yes. We've achieved the goal of proxying something, but we haven't really explained all the benefits and as to why this is done this way, right? Why is thing proxy going through the effort of storing a reference to some thing data, and why is it, getting, setting, initializing from this, and like, why do we go through all this work to further abstract something as simple as I just want to know the details of another class? Well, one of those big points is, again, auto discovery. That's going to be huge, but it also allows for a much better decoupling of hard references between assets and data, and sharing of information in a way that you can't really do otherwise, right? And I think the best way to show this kind of vague point that I have, that I believe has a lot more implications than how I'm expressing it, that are very fruitful to any development team, is that you don't have to have all your actors from the same parent class. The yeet cone, for example, is not a BPA thing actor. It's not. It's just not. So you can see that the yeet cone, while it works within the same system, it has the parent class of actor. So how does this work? Well, I have defined an interface. This is a blueprint interface, actually, called BPI thing. So there's a thing interface, and the thing interface allows you to set the thing, allows you to get the thing. That's all it does. That's the only definition in this interface. And the yeet cone implements it, the base BPA thing implements it, and even the proxy implements it. We'll get to that in a bit. So because the yeet cone implements this interface, this allows us another way to use these thing datas in just our general system of storing, acting, or storing, spawning, managing, doing all these things. Our thing proxy, for example, when it decides to spawn an object based off our thing data, it can do one of two things. The world actor class that our data represents could be a BPA thing. It could be a proper thing class, but it might just be an actor, right? The thing we're proxying, we don't really know what we're proxying. That is sort of the point behind this design, is that the proxies do not need to have the burden of loading and just having to deal with that heavier definition. And it can do a lot with just a very lighter weight model of that. But the downside is we can't actually guarantee the parent class of our thing. And so in this case, we can check to see, hey, is it this first class thing, right? Is it part of this structured mechanic that we have going? If so, we can just spawn it. And because the thing data is exposed on spawn, our actor in its construction script can do whatever it wants with that thing data. And that thing data could be anything that you assign to this. It could, again, come from external data, whatever. The actor will just spawn, and you don't, without any additional logic, without worrying about where this data is coming from or signaling after spawn, you can just consume that thing data and do whatever you want with it, right? That's entirely your own prerogative. But if you're not a first class thing, and instead you're an actor who implements the thing interface, then it's simple. We spawn the class that our data points to, and we just tell it, hey, here's the thing for you. This has the downside of the actor you spawn in its construction script won't have that thing data. It just can't. But it does allow you to proxy things that would be too hard to refactor, or proxy things that, maybe they shouldn't have all the things of your base class if your base class gets too bloated. It just allows for a lot more composing of mechanics rather than just chaining things together and being stuck with a more rigid structure that you might need to change later. So because the proxy is able to deal with first class things and generic actors who implement the thing interface, the proxy is able to do a lot more, and while making sure that everyone writes just a lot less code. And if someone comes along and they need a thing, or they're prototyping a thing, but they don't want a base class thing, they're just trying to get something done, and they just want to inject their gameplay thing into the rest of the system, or they just have other external reasons as to why they need to have their own actor base class. Or maybe, it's a pawn. You're defining a pawn, but a pawn might not be able to be your thing, your first class thing, right? If you're proxying a character, it would be unreasonable to have your characters all subclass the same master thing class that everything else is inheriting from, which is another reason why I prefer the interface method over the stronger singular main class, or having multiple parent classes that you have to switch through and whatnot. Just having an interface on this stuff allows everyone on your team to consume the data and pass around that data freely and respond to it however is best in their development situation of what that mechanic is, if that makes any sense. So when we're proxying these things, we can just say, hey, I have these conceptual ideas of a death orb and a yeet cone, and then the engineers are free to implement those things however they want, which also makes it so that designers can shell out and can make stub data for all of their different items, and an engineer doesn't have to create item data reference design sheets and whatnot. What they can do is they could just open up the data that the designer has already stubbed and work within that same data set and be able to communicate with designers by simply pushing changes to that data configuration. And if a designer doesn't want to mess with the internal mechanics of something and only wants to configure the data, they can reconfigure an item without having the resource allocation block that is, an engineer is working on fixing this mechanic, but I want it to happen a little bit faster, which isn't a mechanic change, it's just a configuration change. But because they have that main blueprint class checked out, I can't actually do my design change. Now, if you use data assets, that problem isn't 100% solved, but that problem is mitigated in a lot of cases. If you want to change the fire speed of a weapon, you can edit the weapon data asset, and if an engineer is changing how recoil is calculated, those two JIRA cards will not block each other because they no longer are fighting for the same resource allocation that is that blueprint file, right? Because the data lives elsewhere, that problem doesn't exist in that case, which could definitely ease up the development of a big game with a lot of people and all that stuff. But it can also just be a nicer working environment, in my opinion. And with these data assets, with these benefits in mind, programmers are empowered to do a whole lot more things for designers that they might not have fully thought was possible, or they're also able to automate things that wouldn't otherwise be automated. For example, if you wanted to automate testing of whether or not all your things can spawn without causing an error, you can do that a lot easier if you have a proxy or if you have this data asset management system. And I will show you that. For example, say if you wanted a zoo of all things. For example, say you wanted a zoo of all your weapons, right? You just want a collection of all your weapons laid out inline, and you don't want to have to worry about, oh, an item was added, a weapon definition was added, a weapon definition was removed, updating the map. It can be a pain to maintain the demo levels, the test levels of your stuff, simply because without an auto discovery system, somebody has to go in and update those things to include the new things. But in our case, here's what I call a thing row. A thing row is literally a row of things, and it's capable of spawning both the actual things. For example, if I put this thing row in here, it works just fine. And if I wanted to test proxies instead with a simple switch, these are now proxies of that data. Now, this thing row, if you look in the configuration of these details, you'll see that there is no configuration for which items I'm spawning, which classes I'm using, anything like that. What this is simply doing, if we open up the thing row, is that it's getting all of the things. Because these are tagged as primary data assets, the asset manager can be queried, hey, give me a list of all of those assets. And this thing data asset that's popped up here, that refers to the project settings that you have to set up in order to get this thing started. This ID here is what the asset manager is exposing for you to reference the things that it collects with this asset base class. So we go back to the thing row. All we're doing here is we're looping through all our things, and this looks complicated, but it's not. All we're doing here is we're finding spots from our origin, and we're spawning the things. Now, we can either spawn proxies or we can spawn the actual thing. It's pretty simple. Spawning a thing in the thing row case is actually adding child actor components, and that's because you can't spawn things in a construction script and blueprint, which is a whole other conversation. But when you have a thing row, you can see here that it's just simply spawning child actors of all the data assets available. And what this means, what I'm trying to prove here, is that if I were to create a new item, we'll just say this is the quit cube, right? I'm going to make a new blueprint, and I'm going to use actor, right? To show that right now in this prototype mechanic I'm building, I have no buy-in into any other systems. I just don't. And I'm going to set this cube's collision to overlap all. We'll do overlap pawn. Overlap only pawn. And we'll give it an overlap event. And when this thing is overlapped, we'll quit the game. Not very useful, but it will demonstrate what we're trying to do here. So we'll test this real quick. Here is our quit cube. And if we walk into this cube, you'll see that it quits the pi session. Great. Now, I want to have my quit cube inform the system, inform the asset manager, inform the team. I want there to be a definition as to what a quit cube is in the context of it being a thing. So in order to make the quit cube a thing, I will make a new data asset. I will use the thing data asset that I've defined fully myself, and I'll call this thing quit cube. Cool. And I'll open this up. I'll set its mesh to cube. We'll use the basic shapes cube, and we'll call this the quit cube. And I'll assign it the world class of our quit cube that we just prototyped, that we just made, and we'll save this asset, right? And we'll delete the quit cube in the world. Now, what's cool about this is if I rerun the construction script on the thing row, which happens on map load, like there's many reasons why the construction script runs, not the point of this video, but you'll see that it automatically adds the quit cube to our thing row. And that is because the quit cube is a thing, which hopefully now, in that moment, you can now see the vast benefits of an auto discovery system and decoupling the data into data management, because now you can automate testing for everything, for a collection like of things. If I wanted to say, hey, are all my things spawning correctly? I can use this in a test map, and I am guaranteed to know that everything tagged a thing, everything data asset is going to be tested. Which means if I add a new thing, if I add a new weapon, if I add a new item, if I add a new character, if I add literally whatever I define data-wise, I know that my automation tests are going to pick it up and they're going to run it and it's going to be tested. I just know. And I don't need anyone else's work. I don't need a single other external perforce change list. When the map loads, when the test map loads, it will do this. And this system is available at runtime. So if you can figure out any need for a runtime auto discovery of your data, you can easily implement that thing. And I have written zero code about asset discovery. I've done nothing except I've defined my data asset and I've defined some mechanical behaviors in the form of my cone, my orb, and my cube. And I've defined data assets that represent those things. And because I have a proxy actor, which all it does is it renders stuff in that data asset, I now have a whole ton of functionality when it comes to testing, prototyping, managing, automating, and just generally configuring design. Like, there's just so many benefits to this system, and it's taken me very, very little amount of work. And again, that's not even including the fact that because I'm using this system, I automatically now support runtime loading of external assets, whether it's new DLC or externally piped in JSON web server stuff you may have built, whatever. If I wanted to have it so that a server can configure game rules, or to use have different preset variants and things, you can send that data down the pipe, and you can, as long as you have a way of ensuring that data assets match on the server and the client, then it skips a whole bunch of other validation you might need to do. It really is just a very solid, easy to use system, but only if you understand what it does and why it does it. But you can only understand that by doing it, which is just, that's the unreal way of doing things, is sometimes you just have to do it to figure it out. And so there's a lot of little details that won't make this so you can jump in right now from this video. But if you look into how to set up a data asset, which the first thing is, I strongly recommend defining a C++ class from uPrimary data asset. And you should also look into defining get primary asset ID. You don't have to. In fact, there's a setting in the asset manager called should manager determine type and name. If you don't define that function, you need this on. If you mouse over the tooltip, it tells you exactly this, that if an asset does not implement this function, then this needs to be on, otherwise it won't be detected. Like, that's just how the system works. And what this function does is, I believe it's just looking for a name, just some sort of unique representation of, hey, this is a unique thing. It's not hard, it doesn't have to be complex, it's just a thing that you need to know. And then again, you can assign whatever data you want. Now, this is just the beginning. This is just scratching the surface of what you can do with this system. Asset bundles is a huge component to this that I have not touched on. And data assets have a very complicated but very rich set of asynchronous loading things that you can do. Now, the blueprint side of this stuff sucks. Just straight up, if you're trying to do asset loading management in Blueprint, you're going to have a hard time. That's not to say that if you're in C++, it's going to be easy either. Asset loading is just hard. Right? It's just a hard thing to do, hard thing to manage, and it's just annoying. But this system allows you to start buying into those techniques, into those things, without having to worry too much about it. it'll allow you to get your stuff done without early optimizing. But if you have time, you can go down the road of, figuring out when you can load things to make things load a bit faster. And that's another good use case for proxies. You can easily have a proxy in your world where from a distance it's one actor, but if you get close, the proxy swaps itself out with the real actor based off of thing data, which is, say you got a large map of a lot of pickups, that would be fantastic. There are just many, many ways to use this data. You can have an instance mesh renderer that is rendering instance static meshes instead of pickups to make rendering of that stuff even cheaper. Like, there are just so many different ways that you can use data assets to configure mechanics. And the fact that they're auto-discoverable is just so important and so useful. And it's one of those things that I think that a lot of people don't realize how useful it could be, because they're not even aware that Unreal can auto-discover assets at runtime and in the editor. And like, there's just a lot of things that people are unaware that Unreal can do, that is doing for you, because buying into those systems is complicated. Using the systems, very easy. Buying into them, extremely complicated. But as you can see with this project, which all the example files for this will be linked down below. You can download the exact project that has all the things that I covered here, has it working. And yeah, so these proxies, again, they don't exhibit the behavior that I've had here. I can go back to making them not proxies, and they do their job. And you can, space them apart, do whatever. Anything. Again, I'm just trying to iterate how useful and how arbitrary game mechanic design becomes when you have a centralized, easy way to query for data. And it makes the whole nightmare of hard referencing classes to extract data from them just go away. But again, the downside is your mechanical actors. So for example, the death orb, the yeet cone, these things, they have to have an understanding of, all right, how do I get the thing? How do I initialize the thing? It puts more work on defining how do things accept data, right? You have to have this logic. Whereas the other way of doing hard references and extracting different classes, the only real logic you need is reference management. But this requires logical management of those references, if that makes any sense. So hopefully this is a decent overview of how I would go about the problem of how do you represent other actors with actors, how do you proxy data, how do you proxy mechanics, and how do you leverage auto-discovery for a bunch of things you might not be considering yet, such as automated testing or ease of development or just what have you. So, blah. If this was useful to you, let me know. This is an hour long. I'd be amazed if anyone watches it.